Good example, good morning. Welcome to the practical number 2 of Unit 2. In this unit, we are going to look at three things. We are going to look at projection and transformation. We are going to look at how to create shapefiles, and we are going to look at how to do georeferencing. Firstly, let us look at projection and transformation. In projection and transformation, without directly jumping onto the practical, let us just introduce ourselves with the geographic coordinate system and projected coordinate system. We have seen in our theory class that geographic coordinate system is the coordinate system for 3D Earth, while projected coordinate system is for a projected 2D or flattened map of the Earth. So we have two kinds of coordinate system, and if you want to just look at the location, the elevation, if you just want latitude, longitude, and elevation of yourself on the Earth, GCS is perfectly fine. That's when we are using handsets like GPS. However, if you want to project it to map, in order for you to calculate the distance, in order for you to look at the size, shape, measurements, and all, then GCS simply is not enough. We need to flatten it, and we need to assign a separate coordinate system called as projected coordinate system. Let us introduce you to some of the data that has both geographic coordinate system and projected coordinate system. All right. In the catalog, first I would like to introduce you to a data or to a layer which has both coordinate system. I'll just bring my Bhutan shape file, and here if I go to the properties of the shape file, I'm saying projected coordinate system here, and the projected coordinate system that it has used is PCS Bhutan graph, and Bhutan graph is based on transverse Mercator, and it has also geographic coordinate system. It has used not WGS 1984, but it has used GCS GRS 1980. So we could have also used WGS 84, but like I said, there are lots of coordinate systems these days. It's on us. Looking at our accuracy, we can use it. We could have also used WGS 84 and PCS as PCS geograph. So these are two things that a map having both the coordinate system may look like. And if you go towards the right bottom corner here, where we have got units, now it is in meters. The main difference between one of the main difference between the coordinate system GCS and PCS is the unit. The unit for geographic coordinate system will be in decimal degrees or degree minutes seconds, or degree seconds or degree minutes. However, if a data that has been projected, or the data that has both the coordinate system and at last finished with the projected coordinate system, will have meters as the unit. And when we have meters here, then we can calculate the distance low, we can calculate the area, we can do any kind of measurement of here. So that's the main difference. Another thing that I want to tell you regarding the coordinate system is that whenever you use the first data, the coordinate system of the data frame, this data frame will be taken up by the first layer that you add to your data frame. That's first thing. Second thing, now if you have added a layer or a data that has both the coordinate system, and next if you add a data that has only geographic coordinate system, then the geographic coordinate system, though it has to show in decimal degrees, will not show its decimal degree, but it is still going to take up the meters over here. The reason is because of the reason number one that I was telling you earlier. It's because the coordinate system that is being taken up by data frame depends on the coordinate system of the first data that we have added. For example, This is also Bhutan underscore WGS dot SHP is also the map of Bhutan, but it has only one coordinate system left. It has no projected coordinate system. It has just GCS left. Let us try to add, and it says that it has only GCS, and that GCS is Geographic Coordinate System WGS 1984 mailer. It's WGS 84 basically, and it says that it has only one thing, and it has not been projected left. Close. Now see, like, it had to be in decimal degrees, but Bhutan WGS now cannot be seen in decimal degrees left. That's because it has taken the coordinate system, the units of coordinate system of the first layer that you have added. All right, that's one thing. Secondly, let us look at the data that has both data having both GCS. Sorry, data having only GCS left, not GCS as well as PCS number. Okay, I'm getting back to the same file here. Bhutan only that this shapefile is having or both GCS as well as PCS. But however, this one, if you just look at the properties of this one, this layer, Bhutan underscore WGS, has only one coordinate system left, geographic coordinate system. GCS WGS GS it has no PCS. So oftentimes you'll encounter some problems where you cannot do any kind of calculations. That's because you have only geographic coordinate system. Oftentimes it comes that you cannot do any kind of geoprocessing or any kind of like modeling or tool running. That's again mainly because it has only one coordinate system. I'll just click it OK, and I'll go to File and tap New and click it OK. I'll not save this one, and this time instead of adding Bhutan first, I'd like to add the layer that has only geographic coordinate system left, the Bhutan WGS. So the first layer that you have added will take the coordinate system and will take up the units layer. Can you see over the lower bottom side now? It's decimal degrees layer. So this the decimal degree is the unit for geographic coordinate system. Please remember this one: decimal degrees or anything that is related with this degree la. Degree millisecond beru, degree seconds beru, degree minutes beru. They are all the units for geographic coordinate system. Decimal degree stands for degree, and minutes and second converted to decimals la. We have degree, minutes, seconds, where minutes and seconds they are not converted to decimal points. We have degree minute time where we are excluding seconds. So these are different file units for geographic coordinate system. In case of projected coordinate system, we have units such as those are which are measurable. For example, meters, kilometers, feet, miles, nauticals, and etc. So these are the difference between geographic coordinate system and projected coordinate system. Right. So we have just seen how the data having both the coordinate system looks like, and how the data that has only geographic coordinate system looks like, specifically looking at the properties and looking at the source and also looking at the units. Secondly, let us look at define projection. Now oftentimes you get a map which has no coordinate system left, and the coordinate system that you have just seen are all defined through this process which we are going to do in a while. Define projection is again important if we have a coordinate system that has been already defined. However, we have to change the coordinate system in order to align our objective. For example, you saw that uh, Bhutan WGS has the coordinate system, geographic coordinate system, uh, WGS 84 में. But uh, this Bhutan, just look at the lower bottom side now. Though the Bhutan is projected one, it has to come in meters, but because the first layer that we have added was Bhutan WGS, so it's still in decimal degrees. However, I'll just omit this one. I'll just go to the layer properties of Bhutan, and I see here that geographic coordinate system for this shape file is GCS 1980. 19 GRS 1980, the WGS 1984, they are quite two different data member. And sometimes we need to define projection in order to change the geographic coordinate system or projected coordinate system to match our other layers. For example, WGS based Bhutan and GRS 1980 based Bhutan, when we are doing any kind of analysis in later part of the process, it will give some problem. So that's the main reason we need to define the projections. So let us try to define projection for those maps which are those layers which are not having any kind of projection, or let us define projection for those layers which have the projection but they are not the projection that we require. So let us just try some practical. So firstly, in due course of time, when we are doing define projection, you will always we can change the coordinate system for Bhutan WGS and make it as GRS 1980, as well as we can add projected coordinate system for this one. When we are doing projection of any data, there are two steps here. Firstly, we need to define the projection, and secondly, we need to project them. To define projection, the define projection has a separate tool in ArcGIS, and define projection essentially aims at defining geographic coordinate system. It gives geographic coordinate system to a layer or to a data. However, in order for us to give projected coordinate system, then we need to project the same layer by using a tool called as project. Sometimes you may come over situation where different projection also works for projecting the data. But the standard protocol is that you use define projection for for giving geographic coordinate system, and project for projecting that layer which has geographic coordinate system just defined through define projection and to be projected. So define projection is one of the tools out of 200 to 300 tools found in ArcMap, and project is also one of the tools that you can also find in ArcMap. Let us just try the two methods. So again, I'm just reiterating. Define projection is for defining geographic coordinate system, and project is for projecting that layer which we have just defined our geographic coordinate system. Let us just define a projection for a map. Let us say that I'll just open a new blank map. Okay, not do this one. I would like to work afresh, and sorry, it's not responding. All right, so I drag Bhutan WGS, and here I would like to right click and look at the layer properties, and I see that it's WGS 84 Musla. I know I'm telling again and again just to let yourself get acquainted with this one. All right, I can firstly give WGS, Bhutan WGS with GCS GRS 1980 because most of the data that we have over here are based on the geographic coordinate system, which is GCS GRS 1980. That means GRS 1980 is the geographic coordinate system. So to give the geographic coordinate system, I need to click a tool called as define projection layer. So in the Arc toolbox, we have a toolbox mainly for projection and transformation under data management tools. And if you go under data management tools, if you go to P, where we have got projection and transformation, and under that one, you'll be seeing two kinds of tools. One is the tools specific for raster over here. If you want to do any projection for raster, we need to get into here under the raster toolbox. But these are outside the raster toolbox. That means these are used for vector files. Bhutan WGS is right now a vector file. That's why we need to use project in this one layer. However, define projection is same for both raster as well as vector. If you look at this one, we do not have define projection under raster. We just have project raster. That means raster project binigi tool. But if you are going outside the raster give folder under the projection transformation, you see define projection here, but not under raster. It's because define projection is same for both raster as well as vector. However, to project vector, you need to click this project tool over here. To project raster, you need to click the project raster tool under the raster box. So to project, to give the geographic coordinate system, I would like to go to define, and this time my aim is to change Bhutan's WGS coordinate to GRS 1980 so that all the coordinate system are same. Input dataset or feature class is Bhutan WGS, and all right, so it's saying that the coordinate system for this has already been defined. That's why you see some kind of like marks over here. But if your layer has no defined coordinate system, then they should be not there. This is a warning sign. Still, then even if it has defined geographic coordinate system, I would like to change from WGS 84 to GRS 1980. For that one, I need to click the option over here, which is towards the right side, and it will be placing me towards a dialog box where we basically see geographic coordinate system and projected coordinate system, and shortcut for the coordinate system which is there in the layers that we are using. So right now the layer folder or the layer that we're using is Bhutan WGS. That's why the layer is using WGS 84, so it's coming by default. The first thing that we need to do over here is that we need to give geographic coordinate system there. So to give geographic coordinate system, we need to go under the geographic coordinate system folder. If you have to give projected coordinate system, then we need to go to projected coordinate systems folder here. I'd like to give geographic coordinate system over here. Then if you're looking at the world here, and if you want WGS 84, it's here. But we do not want WGS 84 right now. It's there already. We want to define another one. We want to go to GRS 1980. That means go to spheroid based, because GRS is based on a spheroid based. So I'd like to go to GRS 1980. So this is GRS 1980 that other Bhutan shapefile or most of the shapefiles under the national data was using. So GRS 1980. I'd like to click OK. Then that's it. I've just have to click OK, and define projection would run, and I'll be getting my results in a while. So that's it. Define projection. Now Bhutan WGS is no more Bhutan WGS. Now it is based on GRS 1980. Now if I have to project it, it's still in under 3D 3D coordinate system. If I have to now look at from 2D 2D map, then I have to project. So in order to project, now I have to click the project tool over here. So uh, let me just get the result of the defined projection over here. So defined projection is completed. It's successful now. And let me see the property of this layer now. And we should be getting our geographic coordinate system changed from WGS 84 to GRS 1980 here. So that's how defined projection works. This is still incomplete because we need to now project. Um, to make our coordinate system shortcut, I'll just show you in a while. Before that one, we need to project now. Um, how to make projection shortcut, I'll just look at in a while when we are doing a projection. So define projection is done. Let us now project that data with project tool. All right, so this file or this layer has to be projected. In order to do that, again I have to go to Arc Toolbox, go to project tool, and this time this kind of dialog box will come out where I have to go to input dataset as Bhutan WGS itself, and it should be saying something else. It already has GCS GRS 1980, and now what more coordinate system that I need from here. So I need to define PCS most. So for that one, I still need to go to the option here, output option, and this time I have to project it out with DukeGraph projected coordinate system. For that one, go under the projected coordinate system over here, and I can go to I can even go to UTM. We had a theory class on UTM to go to UTM N46. So that's go to UTM. But like I said, Bhutan has its own projected coordinate system. That's why we need to go to country. And sorry, it's not under country. Let us look at the national grid over here. And under national grid, we have got Bhutan. And this time I can use anywhere. I can use for these are for specific places. I can use for okay, I'll just use right now for Bumtang, but it should be fine. All right. Then I've just used for Bumtang, and geographic transformation option can be given as well as can be ignored for now. So I'll just click it OK. Or before that one, I have to define output dataset or feature class where I have to save. And with what name do I want to save? I'd like to save it with okay, it's under that one. So I'd like to save it with Bhutan project. So I have projected with project 2, and I just click OK. Yes, the project has been successful, and let us now see the layer properties over here. And if I look at the layer properties, now this Bhutan file should have both PCS and GCS. All right. So right now I cannot see my changes because to see the changes of the projected file, you need to add it again because I have saved it as Bhutan project mostly. This is not the one. So this is being projected now. So I'll just go to new one again. I need to open a new blank map in order to see the changes. It's still with the decimal degrees unit. So I need to go and add a new blank map. And this time I have to add my data, which has now both GCS and PCS. And that data is basically Bhutan projects. Right, I've saved it under this folder where I have for ArcGIS, and this time I've saved it as sorry, this is not the one. I've saved it as Bhutan project over here. So this is the file that I've just projected, and I need to add this one. And this time I can see that the unit is in meters, and it should be having both GCS as well as PCS. So it should be having projected coordinate system, BlueGraph, and geographic coordinate system, GCS BlueGraph. Okay, so that's it with project and define projection. Now I'll just teach you how to make projection shortcuts. For that one, let us just add from a national data Bhutan shift file. Right, for to make our projection shortcuts, I'll just add Bhutan shift file over here, and let us look at the layer properties over here. And the layer properties should give us both the coordinate system. One is PCS and one is GCS, both and two. Now, how to make it shortcut? So, for example, I go to project or different projection. That's fine. And if I let's go to projection, if I just go to this area, then another favorites over here. Right now there's no favorite, so that's the main problem that I have. So I could have added under the favorites. So there's this icon here where you can make the coordinate system favorite, and when the favorite coordinate systems are appearing over here, it will be quite handy, and you can get coordinate system quite easily. I'll just click over here. All right, sorry, I'll just click new or import, and I can import any coordinate system that I want my okay, sorry, it's not import, I have to add. Okay, new, I'll just have to import. I mean, like importing a coordinate system as to make it favorite or to make it shortcut on this dialog box, so that when we are doing define projection and project every time, it will be just there. So I'd like to use for Bhutan, because Bhutan has both the PCS and GCS for similar for most of the layers. That's why. So if I just click like this, then it should be coming under the favorite layer. So even if it is not under favorite, if you have added a right layer, then that right layer should have the coordinate system layer. So I'll just show you once again. I can remove this from favorite to make the coordinate system as a favorite. Just go to drop down, go to import. I can just import the coordinate system of Bhutan, because Bhutan has both PCS TrueGraph as well as GCS GRS 1980. Click it OK, and it comes under favorite. So next time I want to define, for example, next time I'm getting this one, and next time okay, let me check out the coordinate system of this one. Okay, so it's still GRS 1980. If I have to project this one, now I just have to go to projects or define projection, but things should be there, and I just have to go to this icon, and the PCS to graph is over here under the favorites. So you can just have to click OK, and you can click OK directly over here. So this is an advantage of making the projection PCS or GCS under your favorite. So we are done with how to make projection shortcuts. So we are done with the first part of the practical tool. Thank you so much.